I'm Brenna Kelly, and this is my poster, Visualizing Relationships Between Air Pollution Exposure and Pregnancy Outcomes. This project is a novel, hypothesis-generating approach to understanding really large, complex exposure data at the population level. So, we know that pregnancy is a period of increased vulnerability to the effects of air pollution, but most studies haven't considered mixtures of pollutants. Even if they consider one or two, we don't look at the combined effect and how those might be associated with outcomes. In the real world, people aren't usually exposed to just one pollutant, but allowing for interactions between even 4 exposures, which may have non-linear interactions and relationships, makes our models very complex very quickly. So we propose a new approach to understanding high-dimensional relationships between combined exposures and pregnancy outcomes. So we use a cohort of women who gave birth in Utah from 2013 through 2016. The exposures we considered were fine particulate matter, nitrogen dioxide, ozone, and heat. And these were estimated based on residents at a 1 kilometer square grid level. So Utah was divided into this grid. If you're in this area, that was your exposure based on residents. And this is just one example of what that exposure profile might look like during a pregnancy. So for our approach, we wanted to examine all possible exposure types. So we took weekly air quality data for each grid cell in Utah and used a high-dimensional neural network called a self-organizing map. This does exactly what it says. Observations are organized into this 2-dimensional surface representing a state space of types of exposures. So this isn't a geographic map. It does look a bit like Utah, but it's a similar concept. So similar observations are located near each other and dissimilar far from each other on the map. So one type of exposure, so this is made up of thousands of nodes, but it's very fine scale, so it looks continuous. But one type of exposure might be the nodes here. We have low temperature, but high values of the other pollutants, so this might represent inversions. Our next step is to make these exposures more interpretable, and we do this by performing a cluster analysis of the map. So we don't just say you have this very fine scale type of exposure, but you're in this cluster of types of exposures. And then based on the grid cell where a woman lives, we can then see what her exposure looked like throughout her pregnancy. So in the first few weeks of pregnancy, she was in this cluster with this type of exposure, and so on. So rather than dealing with all of these data points, we're just looking at her trajectory through these clusters. And our last step, it's a lot of steps, is to calculate standardized incidence ratios for a pregnancy outcome by cluster week. I think this makes more sense when we look at our preliminary results. So this was the SIR for each week within cluster 3, which was associated with high temperature and nitrogen dioxide and moderately high fine particulate matter and ozone. So it's exactly these clusters here, except this is, I think, just the max, but we had the max and the mean. So when we look at this cluster, we see this trend throughout pregnancy. So women who have this type of exposure late in their first trimester are about 15 to 25% more likely to have a preterm birth. This could be possibly due to poor placental development as a consequence of this exposure. But importantly, we've made this large data set more tractable, allowing us to formulate this hypothesis that we can now go on to test. Thank you.